Hi guys, this is Natalie from Math 300, Spring 2013. I'm here to prove to you the area of a square and a triangle. Okay, so first off, I'm going to state the axioms of area. These are facts that we already know from mathematical and geometrical properties. First, we say for every polygon P, a non-negative real number denoted area P can be associated with the polygon such that the congruent polygons have equal areas. And axiom 2, if P can be cut into two non-overlapping polygons, P1 and P2, then the area of P is equal to the area of P1 plus the area of P2. Finally, axiom 3, if P is a square with sides of length 1, then area of P is equal to 1. Okay, we start off by stating our theorem. This is what we want to prove. So a square has area L squared, where L is the length of the sides of the square. First, what I'm going to do is I am going to draw a square here, and then I'm going to call it A, B, C, and D. Now, we suppose that this square has length sides L. Okay, and then I'm going to draw a similar similar square here, excuse me, and I'm going to do this one as E, F, G, and H. Now let's say that this square has length sides 1, and according to our axiom 3, if P is a square with sides of length 1, then the area of P must equal to 1. So therefore, if this is 1, the side length, then the area of this must equal to 1. Now we can compare these two congruent squares by axiom 1, stating congruent polygons have equal areas. To do this, I am going to compare the side AB to EF. From here, we can say that AB has a ratio to EF, a similar ratio to EF. And this is equivalent to saying that L has a ratio to 1. Now, before we could say anything about the ratios of these two squares, we have to know the definition of a ratio, or what a ratio is. Okay, now to do this, we set up this property here. Let's say we have arbitrary constants A, B, and C. Okay, and then we set up a ratio among them. So we say A has a ratio to B, which is equal to B to C. Okay, now this is the same thing as saying A to B is equal to B to C. Okay, now if we want to describe the ratio between A and C, we could say that A over C is equal to, through some basic algebra here, we can say that this is B over C times B over C. You know, when you put A times C is equal to B times B, and then you divide by C on both sides. But then we want to show that B over C is the same thing as A over B, and we have that here on our first line. So we can just say that A over C is equal to, let's say B over C is equal to A over B, so we have A over B squared. Now this ratio is the same thing as A to C is equal to A to B squared. Okay, now we keep this formula in mind, and then we go back to our ratio here. From here, we could say that we could set up this ratio stating A, B, C, D, or the square ABCD, has a ratio to the square EFGH. Okay, now from our ratio property, we could say that this is the same thing as ABCD to the square EFGH is equal to L over 1. Now we can see that we have to square this from our ratio property, that squared, which gives us L squared over 1. So in other words, we find that the area of our square ABCD is equal to L squared, and the area of our EFGH square is equal to 1, which is exactly what we have up here in the first place, and this L squared is what we are looking for. Therefore, we proved our theorem that the square has area L squared, where L is the length of the sides of the square.